All right. So, good afternoon, and welcome to our sort of virtual open house. I'm Dr. Dave Klassen. I'm the chair and a professor within the Department of Physics and Astronomy. Um, I'm going to try to give you sort of an overview of, first of all, why you should be interested in physics in general, but also then what makes physics at Rowan unique. Um, I'll try to give you a pretty good overview of what's going on in our department, but I do want to give you the caveat that my general area of expertise is astronomy and more specifically planetary science. So there are some things that go on in some of our labs that I just kind of walk by, smile, and nod. But I'll do my best to answer any questions you may have on any of those as well. Um, First of all, again, welcome. Get this working now. So at Rowan, our physics department has about 170 majors. It might be currently around 150. Oh, let me forgot to turn my video on. We should be, so I think we're around 150, maybe 160 right now. It fluctuates right around there. And if you're not familiar with physics departments in general, for a college our size, for a university our size, that's a pretty large number. We graduate almost as many physics majors a year as Rutgers does, for example. So we're a pretty strong department. Yeah, actually we're about a third of Rutgers. We're about the same as Princeton. I got my numbers mixed up, and there it is right in the very next bullet. The degrees that we offer in our department, we have three primary majors. We've got the Bachelor of Science in Physics, and this is the degree that you'd want if you're thinking of going to graduate school, becoming, a quote-unquote research physicist. It also is the degree you'd want if you're thinking about going right into technical industry jobs. These are we've sent students to various places like Thor Labs, Edmund Optics, and now it's escaping me. But these are sort of going into manufacturing type research area, the R&D sections of manufacturing industries. The BA in physics is our second degree, and that one's a lot more flexible, where the BS in physics has about 60 credits within the physics and math areas, specifically designed. The BA in physics has about half that. So there's a lot more room to take more classes, to have more free electives that you can then tailor for your own interests. This typically means that it's much easier to get a double major if you're a BA, or maybe even a whole stack of minors or certificates if you want. The BA is typically the degree for students who are looking to get into sort of what I would call tech adjacent jobs. We've had students go into like sales and marketing for a tech firm. We've had students go off into get a master's in journalism and go into tech writing. One of those, she's actually now the editor of Physics, one of the editors on the editing staff of Physics Today, sort of the journal of introductory physics. But basically, it's wide open with the BA. What will usually means is with the BA, you probably will not be prepared for graduate school in physics or even engineering. So if you're going to do the BA, that's more of this is tech adjacent. The BS is for I want to go into physics directly. The BA is also the degree for those going into education, like say high school physics teaching. That's not to say the BS is you can't do many of these things with the BS. In fact, the way our education degrees are written up now at Rowan, it's just as easy to go into education from either path. And then we have the third one is the BS in biophysics. This is a very structured, rigid program. It's designed so that the person who gets a BS in biophysics is ready to transition into medical school or biomedical research industry or graduate school in biophysics or something biotech related. We have some other things you can do. We've got a minor in astronomy. We've got I forgot to put this on here, we've got some certificates. We've got a certificate in health physics. A certificate is basically 4 courses that are combined together, and you get a separate little piece of paper that says you completed that certificate. We have coming in next spring a certificate in photonics, which is an area in industry that deals with communication and basically using light as a form of communication or a form of study. And then we also have combined programs that lead directly to graduate programs. So you could take, say, the BS or the BA in physics and immediately jump into, say, our high school teaching program at the master's level. And it's a combined degree program so that instead of taking 4 years to finish your bachelor's and then 2 years to finish your master's, you do it all at once and it's only 5 years. So some of the graduate courses are actually taken during your undergraduate years. You pay undergraduate tuition for those courses, and then you transition immediately into the graduate program. And then when you're all done, you get both of your degrees. And in this case, for the high school teaching one, you also have your certificate to teach. We have another one that between our BS in biophysics and a master's in cell and molecular biology with our sister campus down at Stratford, the School of Osteopathic Medicine. And finally, we have a combined program between the BS in physics and the master's in data science. Data science, also known as data analytics, is sort of the area of analyzing and studying big data, looking for patterns, and trying to make well-informed decisions from massive amounts of data. A physics degree is well suited towards this because physics is pretty much all about trying to find patterns in the universe and figuring out how the whole thing works. And this is just another part of that. I'd also like to say that if at any point you have questions, don't feel like you have to wait till the end of the Q&A. You can just type them in. If it seems like it's a digression, I may wait till the end to address it, but I'll try to address every question. If it's germane to what we're talking about, I'll stop right there and answer it. So feel free to just write away as you want. All right, so what to do with a physics degree in general? I've found that starting in physics, trying to explain, especially to parents, what is a physics, like parents understand where an engineering degree is going to go. They understand what a business degree is going to do. Not everyone really gets what a physics degree does. And so I usually like to fall back on a quote I read once that physics is sort of the liberal art, the liberal education of a technological society. So 40 years ago, if you wanted to be a captain of industry, you got a humanities degree, you figured out how people behaved, and you went off and you went into advertising, you went into marketing, you went into general business, and it taught you how to deal with people and move ahead that way. In fact, if you look at like the undergraduate degrees of Fortune 500 CEOs, they're usually in the humanities because they started about 40 years ago. If in the tech world, if you really want to understand the foundation of all technology, that's physics. I have a question about ways to start working on these for my sophomore year. Yes. If you start on any of our programs after a year, there is some catch up to be done. The BA, I will admit, is a lot easier to do the catch up than the BS, but it's still possible. You may need to do some some summers in order to get some of your pre-electives and Rowan core electives out of the way, so that you can spend your time during the semesters focusing on the physics courses to catch up on. But depending on what you've already had, it's really easy to jump into one of these. As far as starting in high school, that's, I think, more a question for your high school. I know we've had programs where high school students have taken our courses, and that would have to depend upon how any articulations between the high school and Rowan. I once taught a class where about a third of the students were high school seniors taking their introductory physics course with us. There's also, we do take AP credits. If you take the APC sequence and pass those exams with a 4 or 5, those count as credit for 2 of our courses, the mechanics and electromagnetism. So that immediately jumps you ahead, basically in your physics by about a year. And that's assuming that you're also taking the calculus, which, we have 3 semesters of calculus required for the degree, as well as some more math on top of that. So what does a physics graduate do? You can look at it by where do they go. They go to graduate school in physics, which really doesn't answer the question about what is physics for. There are applied physics programs, related field graduate schools, going into engineering. There have been surveys of tech industries asking why would they hire physicists when the engineers exist? And their answers have been that if they want a problem solved that no one else has been able to look at or figure out, they hire a physicist. And then when they want to make that problem into something that can actually, fit on a desktop or cost less than $3 million, that's when they then hand over that solution to an engineer. So the physicists are really good at getting the answers. They're not usually so good at constraining those answers to something that an industry can actually produce. So there's this nice symbiotic relationship between the physicists and the engineers in industry, and why industry wants both of them. You could parlay your BS degree into getting an engineering graduate degree, usually like a master's in mechanical engineering or civil engineering or aerospace engineering are really good places to go to from a physics degree. High school teaching in physics. As I mentioned before, jobs in industry, Lockheed Martin, Johnson & Johnson, Thor Labs, Edmund Optical, all these places that make stuff that they need a research and development team to help them create the next product to solve the problems that are coming up. They need someone who can look and see what are those problems going to be. Government labs hire physicists. And the last two may seem interesting to you, the med school and law school. There's an area of law, especially in patent law or legal teams for industry, to figure out what other people have done in order to make sure they're not infringing on patents. So understanding law as well as understanding all the science behind it is a strong thing that people are looking for. Med school, I have to admit that one still also surprises me, but we've sent a few people into med school from our base physics degree. It turns out that if you look at the highest scoring MCAT people, physics majors tend to always be in the highest group of MCAT scores. I guess it's just a way of looking at the problem solving holistically and then getting into applying that to a biological system, which also is why biophysics exists. Just to give you some sort of stats, the American Institute of Physics is really good at polling physics majors and former physics majors to find out what they've actually done. Because again, what is that question of what is physics and what do you do with it is one that is always asked. So in general, these data come from 2013, 2014 BS, bachelor's physics students answering these questions. About almost 5,000 people were responded to their polls. And about half of bachelor's students end up going to graduate school. The rest, most of the rest end up with full-time employment or some kind of part-time employment in the workforce. The employment sectors that they end up in, if they go straight for a job, are overwhelmingly in the private sector. A few stay working at colleges and universities, usually in some sort of tech position. Some go into teaching high school, some go into the active military. That's usually a lot of students. There's programs in the military for paying for your undergraduate program, and then you repay them with time in the military. And so that's where that comes in. And then there's also the government labs, working in civilian government labs or national labs. Of those that go into the private sector, what do they end up doing? This is sort of like, what would your job title be? And over a third end up with job titles that have the word engineer, just because, again, not too many industries have a position for physicists. They hire a physicist into a team of engineers in order to build that synergy between the abstract problem-solving skills of the physicist and then the more concrete, can we do this cheap enough on the engineering side. Some end up in physics and astronomy, other areas of STEM. Computer information systems is another big one, another big area to think about. So one of the things you might want to think about if you're going to come here and take a physics degree, working in there's a couple of certificates over in the computer science department on programming and computer systems, and those would be a really good thing to do. They're a little smaller than trying to get the full-on minor that might be more difficult to do. But you take 4 courses over there and you get the certificate, you've really got a good foundation for programming. And a lot of physicists pick up programming because the problems we're working on aren't necessarily problems anyone's thought of before. So software to solve them doesn't always exist. So we end up having to write a lot of our own code to do what we need to do. So picking up those skills is something you'll probably do anyway. And then you could leverage that in case you figure, hey, I learned some really cool stuff. I can do some really good problem solving. Plus I can program. Now I'm really marketable. As far as job satisfaction, this is one thing that a lot of people don't really consider. But I would really say this is something that should be at the forefront of your mind. If you think I'm going to go be an engineer because I can make some money, great. But if you're not going to be happy, that's probably not the best place to go. You want to make sure that you are satisfied with the job you're doing. And so the AIT measured satisfaction over a couple different areas and asked these students after they, where they were and what aspects of the job gave them the most satisfaction. And they found that overwhelmingly, people who were, the physics bachelors were very or somewhat satisfied with whatever they were doing on this 4-point scale. Job security was usually pretty good. Level of responsibility was good. And these are just in the private sector jobs. Opportunity for advancement was okay. Salary was usually pretty good. I still recall when I was still a fairly young professor, one of my first research students graduated, and it was he was graduating his last semester, and he was looking at jobs, and he got a job offer. He was really happy that he got a job offer, and he came to me and said, I think this is a good job offer. What do you think? And the salary he was being offered was more than I was currently making. I told him I thought that was a very good offer. In the private sector, usually, I think the lowest one here is the intellectual challenge. I think that's mainly because in the private sector, you don't usually get to choose what you work on. There's a problem that the industry needs solved, and that's the problem you're going to work on. You have a little bit less personal direction on what you're going to do. If you go off into graduate school, you go off and become a researcher, at a research university or a government lab. There, you usually have a little more control over what you're doing. But you can see that even so, there was enough happening that they were pretty well satisfied with the intellectual challenge. As far as high school teaching, that's the other one they looked at. You usually hear the general mantra that teaching high school is horrible. It doesn't pay well. Well, those aren't necessarily true. That a lot of that depends upon the kinds of places you end up teaching. In public school systems, for the most part in New Jersey, the pay and benefits are pretty good. The starting pay is on the order of $60K. Benefits are usually better than you'll find in most private sector jobs. So you usually have some pretty good benefits as well as good pay. Job security in the teaching industry is usually pretty good if you survive the first 5 years. There's the whole tenure process where you're sort of protected from outright just being thrown out because you said something wrong. If you have academic freedom in that sense, and so usually you're protected with the tenure process. Level of responsibility was pretty high, and so they were satisfied with how much responsibility they were given for their job. The opportunity for advancement is probably the lowest one here, primarily because there really isn't, right? You're a teacher. Advancement usually comes from either just years on job or you move into something more administrative. And if you don't have any inclination for being an administrator, then there really is no advancement. Salary and benefits, this is averaged across the nation, so some places are worse than others, so overall they were pretty good. The intellectual challenge here is also low because, again, it's a different kind of thinking than maybe a physicist is trained for in their undergraduate, trained for problem solving in general, and most of the problems and the challenges are going to come with just interaction with the students rather than any kind of research agenda driven intellectual challenge. And then there's of course having to deal with administrators and that. So, but overall, even in the teaching positions, very high levels of satisfaction from physics majors. Civilian and government jobs, job security is even higher. Level of responsibility is usually good. Opportunity advancement is okay. Salary and benefits are good. And again, the intellectual challenge is a little bit lower because now in the government lab, you may have some ability to do your own stuff, but you're also working on projects that are being assigned to you based upon need of what that lab has to do. Again, overall satisfaction is good. So physicists typically end up with jobs they like. I think that's the takeaway for this. Active military, I guess again, these ones are mostly off the scale, but that's once you're in the military, right? Advancement opportunities are there. You just keep going through ranks. Responsibility is based on what rank you have. You have well-defined, everything's fairly well-defined in those kinds of jobs. What was your bachelor's degree worth? Starting salaries for physics, you can see right there near the top in red. They range anywhere from mid-40s to upwards of $70,000 a year starting pay. The only ones that really beat us out are the aerospace engineers and the computer scientists. I will warn you that computer science does tend to typically pay more, but that's also a boom-bust cycle for computer science. Usually they go through those waves because everyone sees how much they pay, so everyone majors in it, and then there's no jobs for those people until they all float away, and then all of a sudden they finally need to get people. They need replacements for retirements, and so the pay goes back up again. The reason physics tends to have a much larger spread than just about everything else, again, is just because of the huge variety of jobs out there for someone with a physics degree. And so you can really pick and choose where you're going. So I hope I've sold you on physics. Now let's talk about why physics at Rowan. As a physics major, you'll have fairly small classes. I said we've got about 170 majors. Let's round that to 160 because I can divide that by 4 more quickly. That means that there's about 40 students at your sort of class level at any time. So that pretty much means that the largest class you could ever potentially have is 40 students. And if we bring in some people who are minoring, maybe it gets up to 50. And we almost never have classes that large. Most of our classes are at 30 students for our majors. We do teach our intro courses in a larger format for the as our service courses, but even for our majors, those introductory courses are taught in small classes, 24 students max, and we make sure to give you some of our best faculty for those courses. All of your classes, we really have a strong focus on innovative teaching methods. Since we are scientists, we tend to look at what works in teaching as a science. And there's a whole area of physics education research. And one of our faculty members is an expert in physics education research. And we're regularly looking at how we're teaching, looking at our curriculum, trying to give our students the best possible education and best possible teaching methods. We have on our staff a professional advisor. She's wonderful. She's great. She knows our programs better than I do at times. And I sort of I sort of focused my career on trying to aim at some of this administrative stuff. I, for the longest time, was the go-to on what are the requirements, and now she's our go-to for that. She's the one who will help you navigate the bureaucracies of registration and making sure you hit all those targets. The other thing we have at Rowan is opportunities for research. Currently, we have no graduate programs in physics. And although there's been talk about a master's program in physics, that's probably not going to be a thing for about 5 years yet. Which means that when our researchers need help in the lab, we turn to the undergraduates. And we actually build research into the bachelor's program. The BS Physics has a 2-semester research experience built into the major. You spend time working in a team of 3 or 4 students on a project within a lab. These are fairly small, focused projects, so they have a beginning, middle, and end. You'll learn, how to start a project. You'll learn how to write up, how to give presentations on your project, how to craft a scientific report. All of these things built into these 2 semesters. And then the next year, you can continue doing research with an independent research course that we have. It is possible to get into research as early as your sophomore year. We do have a lower level independent research course. That's primarily for someone who just really wants to get into something right away, but is not sure what they want. These 2 courses are geared more towards, let's say I've got a project that just needs somebody to do some things, and it doesn't require a whole lot of experience. And for lack of a better term, we'll say grunt work. We need someone to go in and make measurement after measurement after measurement using this particular machine. You'll be trained on that machine. You'll make those measurements, and then you'll be handing off that data to somebody. There may be some opportunity to help do some of the analysis as well, but it's far more of a training process rather than an actual research experience. But then in your junior and senior years, you'll actually get real research experiences. We also have an award-winning physics club. I think maybe you can't see there we go, Rowan Physics. There we go. They've won national awards for their participation at the national level in the Society of Physics students. I'll talk about the physics club a little bit later as well. But the big things that we have going on for us at Rowan are the learn by doing philosophy. Okay? You learn by doing research, you learn by doing physics. That's the biggest thing. It's that we really focus on. And so we integrate in our research experiences, you can integrate the abstract knowledge you're picking up in your, say, your E&M class into how does a thin film deposition system work. That's what's being picked. That's what we have pictures of here are a couple of our thin film deposition systems from the material science folks. And even if you're not going to go into that area, let's say you decide you're going to go into industry, well, there are industries that build these machines. And so there are people who are looking for, there are industries that are looking for people who have a very strong foundation of understanding vacuum technology. You need a very good knowledge of vacuum technology if you're going to use a thin film deposition system. And so you gain these marketable skills, even if research isn't where you're going to go. In the BS degree, that research experience will translate into actual physical skills. As far as molecular science, let me talk a little bit about some of our other material science going on and our biophysics that's going on. We have, for a college our size and a program our size, we have a lot of really high-end instrumentation that you wouldn't necessarily find at a place our size. We have a couple X-ray diffractometers. We have an atomic force microscope. We have a scanning electron microscope. We're in the process of setting up a nuclear magnetic resonance imaging lab with 2 NMRs. We have a condensed matter laser lab for making Bose-Einstein condensates, or looking at matter in the lowest energy levels. We have biophysics that's looking at biomaterials, using insect silks to make biocompatible and biodegradable, say, bandaging, internal bandaging. Say you need to get some musculature repaired in your body. You can bind that with these things, close you up, and you never have to open yourself back up again to get rid of whatever it was that was doing the binding after you've healed. At the molecular level, we have a molecular biophysics course, and one of our biophysicists is actually, his primary training is in molecular chemistry. So he's looking at the actual physics of molecules. A lot of work done in the biomedical industry, especially if you're looking at like drug therapies, is looking at the chemistry of how drug interactions happen. But they do this in petri dishes. Well, except the molecules of those drugs aren't going to be working in petri dishes. They're going to be working inside a human cell, which is a very different environment, especially as far as size. And so some of his work is looking at, how do proteins and molecules of these drugs work in the confined spaces of cells. That's physics. It just looks like biology. A little more about our combined degree programs. You can get the BA or BS in physics, and then get the master's in STEM education. We're in the top 15% nationwide for producing physics teachers. I think we might have slipped to 20, but we're still doing well. Physics teachers are in huge demand nationwide. I think because there have been too many years of bad publicity on the pay and benefits for teaching, and that's really eaten in, and also just the bad rep that physics gets for being way too hard. If you get these 2 degrees and you do well, you'll pretty much be able to write your own ticket to where you want to go teach, because they're in such demand. The other nice thing is we have currently a grant. Our physics education researcher has a grant that is helping students get their master's degree. It will actually pay the tuition for the students to get that degree. All the the payment on the back end is 2 years at a high need school for your teaching, but you would get that master's degree for free. You combine the BS in physics with data science. You can combine the BS in biophysics with cell and molecular biology. And again, these are all advanced and accelerated programs. So instead of being the 6 to 7 years, they're going to be more like 5. Our physics club is actually, they just changed. We had a physics club and an astronomy club, and they decided to merge and pool their resources. The Rowan Physics Club's main activities are they staff our open houses for the observatory and planetarium. They staff all sorts of outreach events that the university does. I know it was canceled, but the Philly Science Festival is a big thing in the area, and they're regularly helping out several events having to do with that. They also make visits to local high schools to do physics demo shows and discuss the basic science behind a lot of everyday things. And then they will also do some fundraisers in order to raise money so they can go visit national labs. They've gone to national conferences and presented their research. So they're really active and fairly strong. I think, yeah, that pretty much covers most of the things I wanted to talk about and brag on for our department and physics in general. So I'm going to open it up now for whatever questions you want to toss at me, and I'll do my best to answer them. Again, remembering that details I might be a little sparse on unless you're going to talk planetary science. I'll still do my best. So what questions do you have for me? Am I not getting? Thought I was seeing all the questions. Hold on, let me jump back. Yeah, I saw the question on molecular science. I think the answer to that was yes. Question on getting into the physics program the sophomore year, yes. Being able to start while you're in high school. Again, that's going to depend upon whether your high school has an articulation with the university to let you take university courses. Also, AP credits can count towards courses. So you could do if you do the AP calculus courses and the AP physics courses, you could potentially come in with 4 courses done, right? Just Calc 1 and 2 and 2 of your initial physics classes out of the way by the time you get here. So that shaves off pretty much credit-wise a full semester, if not more, of your time here. Our general physics program, actually you can think of a BS in physics as generally taking 4 courses and then retaking them at a higher level because we skip over some of the detail. Mechanics, electricity and magnetism, thermodynamics, and quantum mechanics are sort of the 4 big areas that we hit on in the introductory level. You've got your optics, you've got some waves and wave mechanics, but optics is really part of electricity and magnetism, and then wave mechanics is part of mechanics. So that's kind of all in there. And then in your sophomore junior year, or in your junior senior year, you'll start taking you'll take an advanced mechanics course, you'll take an advanced electricity and magnetism course, you'll take a statistical mechanics course, which is just a fancy way of saying thermodynamics plus a little bit extra. And then taking something like, quantum mechanics. And then there's the electives that you take. And so both the BA and the BS take those major courses. Let's see, what's the best way to incorporate physics and research as a med student? I would say the best path would be the biophysics degree program that we have. It combines a lot of physics It combines the first entire year of physics plus a little extra, along with the first 2 years of physics plus a little extra. You get the equivalent of 4 semesters of chemistry, a couple semesters of biology, all built into it, and then some very good research experiences. There's a built-in research experience to that degree program as well. It's tailored for working with biophysicists or people in the Department of Molecular and Cell Biology. So you can move around to in that department as well. So I think physics and especially the biophysics is a really good way to get into that area. The other way would be just taking a general BS physics degree and then maybe picking up something like some anatomy classes, some basic bio courses, and some basic fundamental chemistry courses. One of the statistics that I quoted earlier was that physics majors tend to score among the highest on MCATs and are really good at picking things up on their own after the fact. So that if you get the physics degree, because of the way you've learned how to analyze, learned how to, tackle problems on your own, getting into that med school and tackling those new problems is less of an issue. So I think ultimately I would say getting the biophysics degree would be the best first step if you want to go into med school. What other questions do y'all have for me? You're welcome. Well, if nothing's coming to mind right now, I'd ask you to make a note of that email address, physics@rowan.edu. This is a generalized email address that comes to me, to our associate chair, and to our administrative assistant, so that if it comes in, one of us will be able to answer you, and if one of us can't, then one of us will direct you to where you can get the answer, or at least forward that email to the next person who could. We're always willing to answer any questions you have. Feel free to contact us at any time. I would also say you can check out, go to rowan.edu/physics, and you can go there to see our programs, get more details on what the coursework is, see who all the faculty are and what areas of research we have going on. We sort of span the gamut from physics education research, material science, biomaterials, biophysics, planetary science. We have a hardcore astrophysicist. We do some theoretical physics, computational physics, condensed matter physics. We've sort of got a pretty broad range. And so if you're looking for any particular area we probably come close to it. I think you'd have a really good research experience. What is easiest? That's a hard question. And here's where I have to admit to you that as an undergraduate, I found physics to be very, very hard. I struggled my entire way through every physics class I took. Sometimes it wasn't that fun. Other times there was a lot of stuff that was fun. The math parts came easy for me, so that helped me sort of continue the struggle. I made it. I don't know what I would claim as easiest, because it really depends. I usually have found students breaking into two categories, usually within their first year. The ones who found mechanics to be easy, and they tend to be now focused on the physics that you can get your hands on. They tend to become experimentalists. And then there's the ones that really loved E&M, electricity and magnetism, because it was like sort of esoteric, and they kind of got their brains around that. And they tend to lean more towards the theoretical side of things. There are a few that sort of straddle both areas. They tend to be computational in nature. I'm not sure I could answer what is easiest. I can tell you what I find to be the most fun. In physics, I found always thermal physics and fluid physics to be fun. They are by no means the easiest. I'm trying to solve the equations of fluid physics, which is the fundamental equations behind climate science, are among the hardest. And the physics is well known, but making the solutions is difficult. Has to be done computationally, but I'm kind of biased because I'm a planetary scientist studying the atmosphere of Mars. So fluid mechanics is kind of cool to me, as well as interactions of light and matter. So radiative transfer is kind of fun. But that's my bias because that's what I do, and I wouldn't be doing it if I didn't think it was fun. What other questions can I answer for you? Looks like we've got a good 5 to 10 minutes left. If you've got anything, don't don't hesitate to ask. Okay, well, as I said before, make a note of that email address, physics@rowan.edu. And if anything comes to mind after, what's the hardest? So again, that's again for me. It was quantum. Quantum mechanics was my hardest category. Just because it was the hardest thing to get my head around. Um, it's it's also kind of weird and fun if you like that sort of stuff. The idea that the universe is fundamentally quantized, that it isn't continuous, is to me just one of the most mind-bending things. Um, the math behind it was also kind of weird, but again, I kind of liked the math, so that was okay. But just it's very non-intuitive some of the answers you get out of that, and it always made me question what I was I doing the problems right when I would get an answer and it just didn't make sense. It's like, well, yeah, but that's quantum mechanics. So I'd say for me that was the hardest. Um, for others, that's where it really gets fun and interesting, and we've had several students who just dove right into that and just had a blast, and they found that aspect of it to be really fun. Okay. Anything else I can answer for you? Again, you can find an entire list of our courses at rowan.edu/physics. Click on student or click on academic resources, academic programs, and you'll see we've got a list of all our courses. We've got a list of when those courses are offered, um, as well as lists of what courses are needed for each part of the program. And again, if anything crops up later tonight, trying to fall asleep, and you realize some question you thought you should have asked, shoot an email and I'll do my best to answer you. Thank you for your time, and stay safe and have a good rest of the week. Thanks a lot.